Oh, okay. Yeah. So for standard position, you just subtract the angle measurement you're given minus like the whole 180.
Yes, if it is on within the first and the second quadrant.
Okay.
If it is within the first and second quadrant, yes, what you said, what you describe is correct. But if it goes to the third quadrant, if it goes to the third quadrant, for example, if it goes there, then based on the definition of reference angle, we are going to subtract whatever this angle is, whatever this thing is, minus 270.
360?
I'm sorry, not 270, minus 180.
Oh, okay.
Yeah, because 180 is the line that makes 180 is the line that makes
Straight line.
the horizontal angle. So now remember the definition again. The definition says that the angle made by the terminal side. So here is our terminal side. This is our terminal side with the horizontal. So the horizontal here is 180. So if, for example, the standard position angle is if theta is equal to, give me any angle that is more than 180. If theta is
270.
270 will be here, so we don't need that. Give me any number that is less than 270.
190.
Okay, so if theta is 190, so now the whole of this is 190, right? The whole of this is 190, 190. So now the terminal angle, no, I'm sorry, the reference angle, which is here, theta prime, is going to be, 190 degree minus 180 degree. It is like that because the horizontal side is what is used to describe reference angle. So let's do one more thing so that I can give you work to do, and then we take it from there. Okay, so the first reference angle we did was when the first reference angle is when the terminal angle ends in the second quadrant. So we have also done when the terminal angle ends in third quadrant. So the next one we are going to do is when the terminal angle ends in the fourth quadrant. So let me redraw our diagram. And of course, this was your initial angle. So, and then you kept going, and then it crosses 270 and landed here. Okay, and it landed here. All right. So give me an angle that is greater than 270.
310.
Okay, so all this angle from here, the position angle is 310. You see, the position angle is 310. All right. So now remember, by definition, the reference angle, which is here, this one is the reference angle. The reference angle is going to be any angle that the terminal side, this is the terminal side, makes with the horizontal. You see, here's the horizontal here. This one is not horizontal. Here's the horizontal x-axis. Y is the vertical, x-axis is the horizontal. So any angle made with the horizontal and the terminal side is the reference angle. So in that case, for us to get our reference angle, we have to consider the entire 360. So theta here is 310 degree, right? And so theta prime, which is the reference angle, is going to be 360 degree minus 310 degree. So that's going to give us the reference angle, whatever that gives you. So apparently it should be something like 50 degrees. Okay. So now here's the catch. Here's the catch again. Here's the catch. So sometimes you can do this, what we just did right now, you can also do it in radian. You can also do it in radian. As long as you know that 90 degree is equal to pi over 2 radian. And you also know that 180 degree is equal to pi radian. And 360 degree is equal to 3 3 pi over 2 radian. I mean 270. And then of course you know that, let me erase this reference angle and instead write that this place 360 degree is equal to 2 pi radian. Okay? So now let's make an illustration now. I want to make this thing super easy. Let's make an illustration. So give me an angle that is greater than 270, but give it to me in radians. So give me a number that is greater than 3 pi over 2. Am I making sense?
What about 300?
Okay, 300 will work, but give it to me in radian. So find out the value of 300 in radian. So convert 300 degree to radian. Do that very quickly. Just do 180 degree is equal to pi radian. And then 300 degree is going to give us x. So x will be 300 divided by 180 multiplied by pi radian. So that gives us, that's up, basically that's 5. 30 divided by 6 is 5. 18 divided by 6 is 3. 5 over 3 pi radian. Okay, so 300 degree is 5 over 3 pi radian. All right. Now, in that case, our terminal angle is going to be, theta is going to be what? 360 degree is 2 pi radian over 1. Minus 300 degree is going to be 5 pi over 3. Okay, 5, not pi. It should be 5. 5 pi over 3 radian. So now your answer is going to be, so what will you do in order to solve this? You can write this as 3 times 2 is 6, 6 pi over 3 times 3 is 3, minus 5 pi over, this is 5 pi over 3. So your answer is going to be, since the denominator is now the same, it's going to be actually pi over what? 3 radian. Pi over 3 radian.
I have a question.
Yes. Hold on before your question. So what is pi over 3 radian in terms of degree?
Well, pi over 2 is 90. Pi over 3. Probably like, I want to say 60. 60
yes,
degrees.
it is 60. It is 60.
Oh, okay.
So it is 60. So the same thing, if you had done it in degree, it would have been 360 minus 300, and that gives you 60. So it is 60. Yeah, go ahead with your question, Victor.
Are we ever gonna need to do it by radians, like the reference angle thing? Are we gonna have to do that by radians?
Yeah, you can do it in radian, you can do it in degree. The higher up you go in mathematics, the more you are asked to do something in radian.
Okay.
Okay, so now the work I'm going to give you right now is going to be find reference angles, and in finding reference angle, I will include some you can do in degree and some you can do in radian. Are you ready? One more question if you have any before I give you the work. Once I give you the work, I'll give you the time. And once I give you the time, it will now be your responsibility to think about it and complete it and submit. Let's go. Question. All right, so now let's go to our task. The task is, let's go. The question, here's how the question goes. Find the reference angle, theta prime. Find the reference angle, theta prime. Then sketch theta, which is the standard position angle. Sketch theta in standard position, and then label what? Theta prime. So now here is the angles that you are going to find. So A would be 160 degree. B would be 309 degree. C would be 2 pi over 5 radian, and D would be 7 pi. This is 7 pi over 6 radian. Okay, there you go.